So we're going to practice doing some conversions from grams to moles to molecules. So the first one we're going to do is part A, which says 78.9 grams of glucose, which is C6H12O6. And the first thing it says to do is convert it from grams to moles. So I need to know how much 1 mole of glucose weighs. And so I'm going to do my side calculation for 6 carbons and 12 hydrogens and 6 oxygens. So when we tally that all up, we should get 180. So for this calculation, I can see that my grams of glucose have canceled out, and I'm left with moles of glucose. So when I do that calculation, I should get 0.438. So this is the one that goes into the when it says go from grams to moles. Now the next one says go from moles to molecules. So I'm going to start with this number of moles, or I can just continue my calculation. But for now, I'm just going to start with my moles. And I'm going to go to molecules. So remember, there's no abbreviation for molecule, so you have to write it out. So I need to know that for every 1 mole of glucose, I have an Avogadro's number of molecules. Good time to practice doing this on your calculator. So you're going to say the 0.438 times 6.02 times 10 to the 23rd, and you should get 2.63, basically 9, times 10 to the 23rd molecules. So I know that that's a very reasonable number because I know the number of molecules is going to be very big. So my last calculation says I need to start with 2.639 times 10 to the 23rd molecules of C6H12O6. And I need to go from molecules to atoms of oxygen. So I know my unit is going to be, so previously my moles canceled out, and now I'm with molecules. So now I know I need to have molecules in the denominator. And then I'm going to go to atoms of oxygen. So I know for every 1 molecule, there are 6 atoms, because I know that that subscript right there tells me how many atoms there are. So I'm just going to have my previous answer times 6. And that will give me so I should get 1.58 times 10 to the 24th. And then don't forget your unit, which is atoms, oxygen.